Hi, thank you for joining us. So the question we have for you is, what challenges are waiting for us on Mars that the Artemis mission may fall short of preparing us for?
All right, well, great question, because we've got a lot of challenges for us going forward in order to get to Mars. But equally, we've got a lot of challenges, but at the same side, other side of that coin is we also have a lot of technologies and capabilities that are ready to go to get us to Mars. But back to your question about the challenges, to us as an agency and a spacefaring nation, the hardest thing for us, one, is to sustain a human presence on Mars. So Mars, from a geological standpoint, is, you look at everything that we have here around Earth, everything we're used to. We can get water out of a faucet. We've got food in a refrigerator. We have access to everything, shelter, everything we need. You think about how do we get those things onto the surface of Mars, or any planet for that matter. So we've got the challenge around sustaining that human presence. We've got a lot of folks that are working those closed life support systems. One of the areas where we've got a big gap is us really learning how to grow food in space, because we can probably get to the point where we're finding ice on Mars, which means we're finding water, which is the building blocks of life. And if we've got water, that means that we don't have to haul the water all the way to Mars. So that's a huge hurdle or a barrier that's getting a little bit lower for us because we have access to that water. But we need to be able to grow food on space. If we look to the point, looking forward for us, and to me, us making us a multi-planet species, we're going to want not only all of the infrastructure that we have here on Earth, but in order to sustain it, we've got to be able to have structures on the surface. We've got to be able to robotically assemble those to get to the point that we can prepare for humans on any kind of other planet, whether it's the moon, whether it's the Mars. We really have to get to a point that we can go there, we can have robots assemble habitats for us, structures, assemble all of the things that we need for closed life support systems, start the farming, setting up the agriculture and what we need to actually grow crops, so that we don't have to haul all of that stuff and transport it from here to Mars. Because if we can reduce the type of mass that we need to take, that helps us from a whole launch and transit standpoint, reducing that mass. So I think our biggest challenges, one, is the transportation. It's getting us there safely. It's sustaining that human presence. But the other one too that's really important that we don't talk enough about, but it's protecting our astronauts and our crew. And I don't even want to say astronauts, because we want to get to the point that we've got common people like us on Mars. But it's protecting us from space radiation. So here on Earth, we are protected by our atmosphere. And so the sun and supernova at all times are sending these high-charged energetic particles in our direction at all times. A lot of them bounce off of our atmosphere. Some of them come through. But outside of the protective bubble that we live in, you're going to be exposed to these highly energetic particles, this space radiation, and from either galactic cosmic rays or from solar flares coming off of the sun. So you get solar particle events, and those can be devastating to anybody that's in space. So we've got to find a way to properly not only know when that type of solar particle event is going to occur on the sun, and that's a lot of us understanding what's happening there, but it's also getting to the point that we know how to design and build protective structures for our crew in space so that this exposure doesn't hurt them biologically. So again, we're spoiled here with our atmosphere that we've got on Earth. So we've got a lot in order not only to sustain human presence, but to keep people alive and keep them healthy out there. So those are just, I could go on and talk challenges for hours, but those are some of the highlights.
Well, one of the things that we do at Wilton Observatory is we actually use a manufacturing effluent, so we have a destructive analysis lab for meteoritics. And part of the effluent from the destructive analysis lab is actually water that's imparted with all of the minerals that are present in the meteorites as we cover them. So we have taken them and we use the meteorite water in a hydroponics lab in high school to do basically a comparative analysis of growing growing plants in meteorite water as opposed to just plain water. And we find that those minerals help in the growth of the plants quite a lot. So what role does hydroponics and so forth play in our future plans?
A huge role. So there's all different types of technologies and capabilities that they're looking at on how we can properly grow food. But those type of innovative type of ideas coming from academia, coming from private industry, coming from just citizen scientists, right? It doesn't have to be NASA. Those are incredibly important to us. And so I would encourage people to share those ideas with us, to submit to our big challenges, to participate in any of the calls we have for a lot of early research and technology in that way. And I'll make another point on that when I say that the reach and those ideas come from different places. That's what's really different about this Artemis mission and where we're going with all of this, is that it's not just NASA. It's not just a bunch of, smart NASA geeks sitting in a room figuring out, no, we're doing this as a collective, as a country, and really as globally, where we are pulling from the best in academia, the best in industry, the best from across of government, but we're pulling from people who may have ideas who are sitting in some place that's not typically NASA oriented, right? So, we could have a third grader who comes with some idea that could just completely revolutionize. To me, that's exciting, and I think that ideation and us learning how to harness and really crowdsource. We are almost crowdsourcing ourselves back into the solar system, and that diversity of thought, that's so powerful. But back to what you guys are doing, those types of things will definitely play roles in how we can have sustained human presence. And the food piece, I told you, is one area that we're doing great work on it, but I think that's one area that we can continue we've got a lot of maturity, I think, that needs to come in that area.
Well, thank you very much.
So you're welcome.